it. This is a knob. Now let the knob be at position X. The voltage which I am supposed to apply. Here, what is this? The value of Ig? Let it be 10 milliampere, and G equal to 10 ohm. What is the value of Vg equal to? Vg equal to Ig into G, 10 into 10 to power of minus 3 into 10. So what is the maximum voltage it can measure this galvanometer? 0.1 volt. So I want to increase the range. Let it be 1 volt. Let this be 10 volt. Let this be 100 volt. You can choose any value, 80 volt. It can be like some 70, so like a 130 volt, anything. Just I picked up some values, 110. So there's a knob. Now the voltage which I want to measure, I'm going to apply it now. So this will be V1. How much? 1 volt. Now the current Ig will flow like this. So what is that? V1 equal to 1 volt. V1 should be equal to Ig into G plus R1, writing KVL. What is the value of Ig? 10 into 10 to power of 3. V1 is 1 volt. G is 10 plus R1. So this will be 1000. 100 equal to 10 plus R1. R1 equal to 90. So there's a value of resistance I put it. Now I'll rotate the knob. I'll bring the knob to the position of that's the second thing. I'll bring the knob to the position like this. Then how much the range? Range will become now V2. This will be 10 volt. So now no current will flow. What all that current Ig? It has to pass through the branches like this. So what should be the value of V2? V2 should be equal to Ig into G plus R1 plus R2. This will be 10 into 1 milliampere. 1 into 10 to power of minus 3, 10. R1 we got 90, and this is R2. 10, this will be 1000. And that plus R2. 10,000 is equal to 100 plus R2. R2 is equal to 9,900. I think it's still justified, no? As the range increases, what should be the resistance that should be connected in series with galvanometer? That should increase. Okay, this is what you can see now. R1 plus R2 it should be now. Okay, the last one. And now the range will be V3 is equal to, we have chosen 100 volt. So the knob will be the value of Ig. This is Ig, this is Ig. So applying this KVL, V3 equal to Ig into G plus R1 plus R2 plus R3. This is 100. 1 into 10 to the power of minus 3, 10. R1 was 90. Value of R. So solving will get value of R3. So this is about the multi-range voltmeter. This was a little bit easier. There you have to work out. So as the range increases, the resistance to be connected in series with also will increase. Any modification can also be done. You should be ready for that. I'm making things clear. Anything can be modified here. This is one basic circuit I'm giving. Even if you get one resistance in series in parallel here, so don't get scared. You can just carry on with the problem. Even in multi-range also, I can do some modifications with some R naught. I'll keep it. Then also you can manage here. Can be modified. So don't think that it should be like this only. But what is the basic idea? At the range, the range increases, the resistance that will come in series with galvanometer must increase. Any modification they do, there'll be some specific reason, not to just make a question. I'm making things clear. It should be meaningful modification. Okay, so even voltmeter also we may come across. Even voltmeter also it can be off like this. Huh? Even voltmeter also we can. So they may ask you what is the range of this particular voltmeter. So what is the value of Ig? Ig, let it be 1 milliampere, G equal to 10 ohm. I'll ask you like this. You should not get surprised, sir. There is a 10 ohm, is there what to do? So no, you say that any role that 10 ohm plays here. Any role that 10 ohm plays. Let's write KVL. There's something different, huh? Not related to the above. So Vmax is equal to, there'll be a flow of current, here Ig. So here some current will flow, say I naught. So Vmax equal to Ig into G plus, call this R1. This is say R naught. It depends upon only on that one. So any value of this R naught, will it have any impact on this? Because it be parallel to this. So look at the range. It just depends on R1 only. Even if this resistance R naught is variable also, it will not have any impact on the range. But it is used to, it is brought to protect the galvanometer. Some situations are there. So don't get confused here. Let it be that one. Even for voltmeter also, let there be one resistance in parallel. Some of the designs they do go for like that. But the range again depends on R1 as a very R naught. So anything will happen. So here the range of voltmeter will not change. But as the increase R naught, the increase R naught, the current through it what happen will increase. So the current through it will decrease here. Current through it will decrease. So that particular thing what happen is going to take care of that one. In some circuits, they do take help of this for some application. So here the range is independent of R naught, at least you can say here. There's a voltmeter, I'll write it clearly. Vmax is independent of R naught. Okay, let's go for infinite